So I know this video should be only 4 minutes long, so we're going to go over a couple of the product terms. So first, looking at W prime, we see that W prime is basically these two rows which have zeros included in them. So then we would make sure that this is not an implicant at all. Next, we want to look at XZ. So when X is 1 and Z is 1, this is the example we went over earlier, which is this middle box or this middle group, which we can determine that it is an implicant, but is it a prime implicant? If we remove the literal term Z, then X, which is these two middle rows, includes 0, which is not valid. And if we remove X, then these two columns for Z also include 0. So there's no possible way to make this group larger, which means that this is in fact a prime implicant. Is it essential? Okay, so an essential prime implicant is one that covers at least one cell not covered by any other prime implicant. So looking at WX as we determined was a prime implicant before, this is covering this one. And if we look at this grouping right here, this is also a prime implicant because you can't make this group any larger, meaning that both of the ones are covered. So that would mean this is not an essential prime implicant. Moving on, we have W prime X Z. So W prime, look at the zeros, X, this row, and then Z, which would be this group right here. And we can notice that what we talked about earlier, the removal of this literal results in the same product term. So even though it's an implicant, it's not a prime implicant because this group can be made larger. Y prime, going over this quickly so we can go over the essential prime implicant. We have Y prime, which is these two columns right here, which include a 0, making this not valid. So it's not an implicant. Now, looking at XZ, we see that XZ are or is the group with the four corners. And we can determine that this is an implicant and it's prime because we cannot make this group any larger because there are zeros right here and here. Now, is it essential? We see that this is bordered by two zeros and a D. There's no possible way that another prime implicant can be made a group with this one. So therefore, this is in fact an essential prime implicant. And finally, since we're running out of time, I'm going to go over one more example and everything else should be straightforward from there. We want to have all of the essential prime implicants in the minimal sum of products form. And after removing dominant prime implicants, we repeat the process to keep finding these essential prime implicants to find our final expression for our minimal sum of products. So looking at x prime yz, we can also notice from the previous product term that if we remove the literal y, then this creates the same group as x prime z. So it is an implicant. So if we look at x prime y z, or x prime y z prime, it would be this grouping right here. And we can make it larger into the same group that we determined was an essential prime implicant right here. So basically this means that this is an implicant, but it's not a prime or an essential prime implicant. Thank you guys so much for listening. I hope you guys learned a lot, and thank you very much.